Have a good day. My name is Purushottaman Pillai, son of Sanasi Pillai. My text number H20A1716 is going to present my part, which is question 1 from part A. I choose 30 samples randomly from the appendix given. These are the samples I've used to describe the data. Okay, these are the size sample, which is 30 sample, and the class width is our chosen maximum rate is 314.0, the minimum is 209.5. So to the calculate, the formula is max entry minus with minimum entry divided by number of class, which is 314.0 negative by 209.5 and divided by 5 equals to 20.9, and we need to round off in make it 21st. Okay, this is the first table, which is class and frequency. There are stated the classes and frequency according to the data. There are total 30. To get the class data, which is we need to take the minimum 209.5 plus with the class width to get 229.5, and the same goes to the 230.5 plus with class width, which is 20.9, and we will be getting 250.5 and following by the rest. Okay, for the second table, there are 4 elements, which is class, frequency, relative frequency and cumulative frequency. The formula for find out the relative frequency is frequency divided by the total sample. The answers are stated over there. To find out the cumulative frequency is we need to calculate all over the frequencies. For example, the first one is we need to state over there, which is 3. The following by 3 plus 9 equal to 12. 12 plus 5 equal to 17, as that.
Assalamualaikum. Hi, my name is Nuliana Amira binti Zakaria, metric number H20A1629. Today I want to present my part, which is part A, graphic method. So this is our first graph. It's frequency polygon. As you can see, the table show about class, midpoint and frequency, which were taken at random and taken into account. We must follow the horizontal scale is the midpoint of the data values, and vertical scale measure the frequency of the class. Next, for the second graph is ogive. The plot point they represent the upper class boundaries and their corresponding cumulative frequency. The graph starts with upper boundaries. It is 209, where the cumulative is 0, and the end graph is 359, cumulative is 02. A ogive graph is a line graph that displays the cumulative frequency of each class its upper class boundaries. The specific, the horizontal and vertical scale is horizontal for the upper class boundaries, while the vertical is cumulative frequency.
Hi, Assalamualaikum. My name is Farah Ismana Zabin Rosli, and my metric number is H20A1135. And in this video, I would like to talk about measure of central tendency, measure of variation, and measure of positions. So, measurement of central tendency provide information about typical of or average value of the data set. This central tendency is a single value that attempt to describe a set of data by identifying the central position within the set of data. So in this central tendency have a 3 part. There is a mean, median and mode. Mean is the average of all data number. The formula of mean is x equal total frequency and midpoint divided by number of the data. According to data that we collect, the mean of our data is 264.0C. So the mean price of bungalow for given size is RM 264,060. So the second point on the measure of central tendency is median. Median is the middle data of the number data that has been collected from the table. The formula of median is lower boundary of middle class plus number of data divide 2 minus total frequency median minus 1 divide frequency median times class width. So from the data we found that the total median is 236.6. So the median of our data is about 50% of practical bungalow given size less than RM 236,000 and the others more than RM 236,000. So and the last point is mode. Mode is the common most number of data set from the table data. For formula of mode is lower boundaries of mode class plus to the changes before frequency of mode class divide to the changes before frequency mode class plus the changes after frequency mode class time class width. So from the table that I show is our total mode is 242.6. That means the highest price of bungalow with given size is RM 242,600. Now is a measure of variation. According to the table of total number of price of bungalow, we have calculated the variance by following the formula is S equal 1 divide number of data minus 1 times the total of frequency midpoint square minus total of the following frequency midpoint square divide number of data, and the total that we calculate is 67007.75. For standard variation, we calculate use the formula S equal root S squared. The answer is 258.85. Therefore, the sample variance is about RM 6700.75 and the sample of standard variation is RM 258,850. So the last point is a measure of position. A measure of position is a method by which the position that a particular data value has within a given data set can be identified. To determine the measurement of position, the data must be sorted to defining such a measure. To determine the measure of position, the data must be sorted from the lowest to highest. From our table that I calculate, our Q1 is 7.5 and the class interval is 230.5 until 250.5, and while Q3 we got 22.5, the class interval is 272.5 until 292.5. The total of the Q1 we got is 23.6, while the Q3 that we total all is we got 272.89 and 86. Shape of data distribution is our mean is RM 264,016, while our mean is 236,600, and our mode is 242,600. So our mean is a big than median, and our median is small than our mode. So therefore it is skewed to the right.
Hi, Assalamualaikum. My name is Siti Hajra binti Yusof. Metric number H2O-A1767. So, first of all, I want to present about my part of this statistic assignment. Okay, the table below are the data of income and expenditure of household by income class between 1,500 ringgit until 1,999 ringgit in Malaysia from the year 19 from the year 1970 until 2019. The data I collected from portal of the Union of Economic Planners shows even though the income was decreased at one time, but the expenditure still does not affect it, because expenditure are independent and income are dependent. As we can see here, from year 1970 until 1995, the income and expenditure was increased from year to year. After that, year 1997, the income was dropped, but the expenditure still remained increasing. Starting from year 1999 until 2019, the income was decreased slowly year by year, but the expenditure remained not stable at early stage, but suddenly slowly dropped by years also. I think for now that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And my name is Muhammad Kamal Daniel bin Wirazimi. My matrix number is H20203. Okay, so I will continue from the J part. This my question is question 2. It's about if the data set consists of more than 100, then you may select a random number. Okay, so my answer for the question B is N is same by 27. It's because what? From the 1970 to 2019, the year from that is 27 years. So my data consists is N is 27. Okay, so based on that, the income, the expenditure, I will count it. Okay, for the income is about 232 for the x by square, and for the expenditure is 283 for y by square. Okay, I think that's all for me. Thank you.
Hi, Assalamualaikum. My name is Balkis Nur Atira binti Muhammad Zulmizan and my metric number is H20E1887. Now, I will present part B, question number 3. For question 3, I need to compute the Pearson's product movement correlation coefficient. Then, I will explain the value obtained. First, we need to find summation of x, summation of y, summation of x square, summation of y square, and summation for x times y. The formula for Pearson's equation is summation of x times y minus summation of x times summation of y. Divide by n over square root of summation of x square minus summation of x to the power of 2 over n minus with summation of y square minus summation of y to the power of 2 over n. Then I substitute the value that I get into the formula. I will get 238.1181 over square root of 456.4696 times 687.7407, and the final answer would be 0.425.
Hi, my name is Savivatri Medikopal. My metric number is H20E1744. I'm going to present my part, which is question 4 from part B, and the question is develop the estimate regression equation, then interpret the regression equation, calculate manually. So the formula is B1 equals to summation xy minus summation x summation y over n divided by summation x square minus in bracket x square divided by n, which is 2,670.87 minus in bracket 232.1 in bracket 283 over 27 divided by 2451.67 minus in bracket 232.1 square divided by 27, and the answer is B1 equals to 0.522. After find B1, need to find B0, and the formula for find B0 is B0 equals to Y minus B1 X equals to summation Y divided by N minus B1 summation X divided by N, which is in bracket 283 divide 27 minus 0.522 in bracket 232.1 divide 27, and the answer is B0 equals to 5.993. The regression equation is Y equals to B0 plus B1 X, which is Y equals to 5.993 plus 0.522x. So the slope is B1 equals to 0.522. For every income increase, the expenditure will increase about 0.522%, and the constant is B0 equals to 5.993. When the income is 0, the expenditure is 5.993%.